Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! It's really important when answering this question that we're really methodical. So, we're going to start off just looking at steak. And I'm going to start off with the S. And we're going to pair it with the first dessert, which is the I. Then we're going to pair the steak with the second dessert, which is the mousse. Then we're going to pair it with the third dessert, which is the fruit. So we're being really methodical. We've done all of the combinations with steak. And so we're going to look at burger next. And we're going to pair it with the first ice cream. Then burger. And we're going to pair it with the mousse. And then finally the burger we're going to pair with the fruit. As long as we do things methodically, we don't ever miss any. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more. So she will have 516. And Robert has 69 fewer. So we're going to take 69 away from that. And that will equal 60. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by minus 3 because they're minusing 3 each time. So we know that the number before the n is going to be minus 3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3 and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the minus 3n. So it's going to be add 20. So our answer is minus 3n plus 20. We need to first of all work out the theoretical probability. And to do that, we do the successful outcomes over the total number of outcomes. So here we're asked, it lands on a red is successful, so that's going to be 15 over the total amount, so that'd be 40 plus 30 plus 15, which is 85. Okay, now to find the expected amount, it's just the theoretical probability, which is 15 over 85, times the amount of trials, where it says it's spun 500 times. We just go times it by 500. And we get the answer of 88.235, blah, blah, blah. And we're always going to round that down Okay, so if it's 88.9, we're always going to round it down to 88. Only when it gets to 89 do we write 89. So our answer is that we're expecting roughly 88. So here we're asked to factorise a quadratic, and we know it's a quadratic because it's got an x squared term, an x term, and a number term. And what we're going to do is we're going to be, first of all, putting two sets of brackets down with an x at the start of each. And what we're trying to find is what number goes here and what number goes here. So we're going to start by looking at this minus 45. And it's a special number because we're looking for two numbers that multiply together to make that minus 45. We're also going to look at this plus 12 here because we're looking for two numbers that add together to make that 12. So what we can do is write out the factors of minus 45. And so that's going to be minus 1 and 45, minus 3 and 15, minus 5 and 9, and then the same but the other way around. So 1 and minus 45, 3 and minus 15, and 5 and minus 9. Remember, we're looking for them to add together to make 12. So we look down the list here, which ones add together to make 12. This one here, minus 3 plus 15 is 12. So our answers will be minus 3 and plus 15, or the other way around. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represents plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared, and it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So we're given a right angle triangle here, and we're asked to find length AC, which is this length here, and we're given the 2 other lengths. So we're going to be using Pythagoras. Pythagoras involves us labelling the sides A, B and C, with C being the one opposite the right angle. And we know Pythagoras is A squared plus B squared equals C squared. Both A and B here are 4.9, so it'd be 4.9 squared plus 4.9 squared equals C squared. So we're going to add the 4.9 squareds together, and that will give us 48.020 blah blah blah. And here we're going to do a bit of solving. So we're going to square root both sides to find out what C is. So square root of 48.020 blah 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 is 6.929 blah blah blah. Rounded to 2 decimal places, this will be 6.93. Whenever we solve, we've got to get rid of any fractions or brackets first. Now looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them, and you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we'll take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. To prove triangle congruence, you're going to have one of 4 answers. You're either going to have RHS, SSS, angle, angle, side, or angle, side, angle, and the last one, side, angle, side. So those are our options. So we've got to figure out what we have in this question. Well, we have a right angle, so an angle or right angle. We've got a side, which is actually the hypotenuse, because we know the hypotenuse is opposite the right angle. And then we just have another side. Now, it's not going to be SSS because we don't have 3 sides. We do have a side and an angle and a side, but the 2 sides are not next to the angle, so it's not going to be that one. And we don't have 2 angles, so it's not going to be this one. So the last one is RHS, which is right angle, which we have, hypotenuse, which we have, and side. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. To find an error interval, what we need to do is find the smallest and largest that a number can be. So I start by just drawing a quick number line, and we put our number in the middle, which is 89.6. Now we're looking to the nearest tenth, so what I'm going to do is I'm going to write down the next number down and the next number up in tenths. So the next number down would be 89.5, the next number up would be 89.7. Now the bounds, the upper and lower bound, the maximum and minimum number it could be before rounding, are going to be at the halfway points. So here and here. And so all we need to do is work out what those numbers are. So halfway between 89.5 and 89.6 is 89.55. And halfway between 89.6 and 89.7 is 89.65. So those are going to be our lower and upper bounds. But how do we show it as an error interval? Well, we put t in the middle because it tells us that t is representing the time. And we show it with inequalities. Now, the number can be 89.55, but it can't be 89.65 because that would round to 89.7. So we say everything that's less than but not equal to. So we're looking for the acceleration between 3 and 5 seconds. And acceleration is calculated by the change in velocity. So we're going to see how much the velocity's changed So it started at 90 and it's gone up to 200, so that would be 110, over the time. Now the time is 2 seconds, so it's going to be 110 divided by 2, which is 55. And the units will be the meters per second, because that's kilometers, sorry, that's velocity, per second, or meters per second squared. And so it's 55 meters per second squared. So there are 3 parts that we need to find the area of. We're going to start with the easiest bit first, this circle at the bottom here. Okay, so the circle area is just going to be pi times r squared, and the radius is given to us at the top, which is 9, so it's just going to be pi times 9 squared, and that would be 254.469 blah blah blah. Well, we could leave it as 81 pi. Next bit is the curved bit of the cylinder, so we're going to do the cylinder next. And it's just the curved bit, and the formula for that is 2 pi r h. So 2 times pi times the radius, which is 9, times the height, which is 30, and that will give us 1696.460 blah blah blah. And the last bit is this hemisphere here. And so let's do the hemisphere. And the formula for the area of a hemisphere, well, this full sphere is 4 times pi times r squared, but because it's a hemisphere, it's half of that. And so it'd be half times 4 times pi times the 9 squared. And that will give us 508.938. And so the final thing is to work out the total area, so total surface area. And we're just going to add up all these numbers together. So we add up the 254.469, the 1696.460, blah, 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 and the 508.938, blah, 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 blah. And we get 2,459.867, blah, blah, blah. Do make sure you show the examiner that you're adding these 3 here. I've not done that because it wastes a bit of time for a video, but make sure you write it down. It says it wants it to 2 decimal places, so that will be 2,459.87 centimeters squared. To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to 2 decimal places, so that will be 19.99 centimetres. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12, fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile, and we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down, and that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. We're going to first of all get x equal to the 0.151151, blah blah blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000, and we'll get 151.151.151, blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1,000x take away x would be 999x, and then 151.151.151, etc. Take away 0.151151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. We're going to write this out again just to give us a bit more space. So we've got s equals 4 minus 13t over t minus 5. I'm going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be either way around, so I could have 5s plus 4 over 13 plus s, or anything like that. So we're going to start by labelling the sides here. So we've got capital A up here, little a down here. It doesn't matter which one you label. Capital B here, little b here, and capital C here, little c here. So you notice the c's aren't really involved at all, but we've got the two a's, we've got the capital A and the lowercase a, and we've got the capital B and the lowercase b as part of the question. And so when you've got a pair or two pairs of angle and sides, you are going to be using the sine rule. And so the sine rule says that sine capital A over lowercase a is equal to sine capital B over lowercase b. Now you might be wondering why I've put sine A and sine B at the top, when sometimes this is written as the lowercase a and lowercase b at the top. Well, if we're looking for the angle, which we are here, we're looking for capital A, you put the angles at the top. If you're looking for the length, you put the lengths at the top. Okay, so we're going to fill this in. So sine, we're just going to leave that as sine A, so it's just, or sine x actually, shouldn't it be? Sine x over, and then lowercase a is 6, equals sine B, the angle is 35, over lowercase b, which is 7. Okay, we're going to work out what the right hand side is. So that's going to be 0.081 blah blah blah. And then we're going to be solving this. And the first thing we're going to do is times by 6 both sides. So we get sine x is equal to 0.491 blah blah blah. And then we're going to inverse sine both sides. And so we have x equals 29.448 blah blah blah. And our answer wants to be rounded to 2 decimal places, so we're going to put our answer as 29.45 degrees. So we know the cuboids are similar, so there's going to be scale factors, and we're given the two surface areas, so we're going to first of all start there, and we know that there's going to be a scale factor between them. So what do we times the 9 by to get to the 272.25? So we're going to do 272.25, the big one divided by the small one, to find out what the area scale factor is. And when we do that, we get 30.25. So the area scale factor is 30.25. Now this question is all about volume, but we're going to work a little bit backwards, and we'll find out that the area scale factor is the linear scale factor squared. So we're going to work out what the linear scale factor is. So to find the linear scale factor, we're just going to square root the 30.25, the area scale factor. And when we do that, we get the answer of 9. So square root, 5.5 even. Didn't sound right. Okay, so when we square root that, we get 5.5. Now, we know that the volume scale factor is equal to the linear scale factor cubed, because there's 3 dimensions. So we know it's going to equal 5.5 cubed. And so the volume scale factor is going to be 166.375. Okay, so that's the volume scale factor. Now we're given the larger cuboid has a volume of 8984.25, and we're looking for the volume of the smaller one. So with scale factors, to get from the smaller to the bigger, we times it. To go the other way, we just divide. So we're going to divide this by 166.375. And then when we do 8,984.25 divided by the volume scale factor, 166.3275, we get the answer of 54. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realising is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. In this question, it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters. And we're looking to find the area. Now, we also know with an equilateral triangle, all the angles are 60 degrees. So we can plot those, but we don't need to plot them all. We can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with a, b and c, it doesn't matter what you label a, b and c, as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator and we get the answer of 43.301, blah blah blah. It says it wants it to 2 decimal places, so that is 43.3. To answer this question, we're going to do something a bit weird on the calculator, and this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398, blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309, equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.9 0.975, blah blah blah. We're going to work out the volume for A, and this time it will be a third times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah blah blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah blah blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.